Okay, morning. Today we're going to do how is Mohs Circle related to materials use strength. Okay, so we usually teach Mohs Circle, but how is it related to the real world? We have problem. Okay, the element is the real world. Okay, once we draw in the element is a real world. Then after that we go into 3D Mohs Circle. Just a reminder, term test 2 is today, March 14, 7 to 9:30 p.m. Term test 2 correction. Okay, if you did not do well, which I don't expect a lot not to do well, the correction is the following week at 7 p.m. to 9:30 p.m. You will know whether to rewrite or not on Friday evening. Okay, on Friday evening, okay, the correction list will be posted on Avenue to Learn. Okay, so those of you that need to do correction, I'll post it. Okay. Right. So now I'm going to any questions so far? No? Okay. So how is Mohs Circle relate to material use strength? Okay. I know sometimes it's very obvious, but usually it's not. So what do I mean by material use strength over here? So you usually we do a test. Oh, go on. Usually we carry out experiment, uniaxial test. So the uniaxial test usually it is in one direction only. Okay. So this is your stress X. Okay. So this is our X. This is our Y. And this is our Z. Okay. So we carry out uniaxial test for this case. Specifically, I would say we carry out a tensile test. Then from here, we plot a graph, which you guys are all very familiar with. Right? So you have stress and strain. And then in this first section, as you all know, it will be linear. And then you will have seen something like this. So this dot point that I point down here, this is our U strength, as you know by now. And over here is our ultimate strength. Then point X is where you see we have fracture. So we will divide this. I'll just briefly go through this quickly. There are two selections over here, two regions over here. On the left-hand side is our elastic region, and on the right-hand side is our plastic region. So 3AO3, everything is elastic. Plastic is 3CO3, right? As you all know by now. So how is this related to, how is the U strength related to Mohs circle? So when we construct Mohs circle, okay, so now it's Mohs circle. So when we construct Mohs circle, we usually construct, let me do below, okay? We usually construct Mohs circle based on an element, okay? So we get our stresses from an element. Or okay, before we go there, we have structure analysis. right? So we carry out structure analysis. So for example, our structure in 3D, we have a structure looking like this. And this is just an example. Or it stops over here. Maybe this is not a very well drawn structure, but anyway. So we have a structure over here. Right, then we have a base. Right. Built in, then we have our element. Element is the point of interest. Okay, this is our element. H, for example. Then we have our forces down here. Okay, we have our forces. So I'm going to call this our X. I'm going to follow the transformation over there. This is our X, our Y, and this is our Z. So this is our PX, PZ, and then we have another force acting down here, which is our PX, and then we have another force acting down here, which is our PY, right? So from our element, right, we reconstruct an element. This is just a sketch, okay? So this is our element H. Okay, so you have our normal stress. Okay, so we have our normal stress, and then we have our shear stress. Okay, so this is shear. It's very early in the morning. ZY, is it ZY? Intersecting plane is on the Z. Yep, Y, and this is shear YZ. Okay, right? Now, so this is our element. Okay, this is our element. Okay, before I go on, over here, in fact, when we do our stress strain curve, okay, for the unit axle test, we also have our element down here. Our element H is here. Okay. Now I'm going to ask you a question now. If you look at the two elements, right, are they loaded the same way? Yes or no? The one on the top is uniaxial, the one below is under combined loading. Are they loaded the same way? The answer is no, right? It's not loaded the same way. Okay, it's not loaded the same way because on a uniaxial test, right? On the uniaxial test, our stress in the x direction is equal to px over a only. Yes or no? Right? It only has what? Normal stress. Okay. So we still construct Mohs circle for this case. Okay. So sorry, we still construct Mohs circle on the uniaxial test. So this is our uniaxial test. We only have what? Stress x. Okay. We only have stress x. Then once we start drawing, this is just a sketch. Okay. Once we start drawing Mohs circle, this is our normal, our shear stress. Over here is our normal stress, right? So this is our normal stress, shear stress, and over here this line, that I'm constructing, this is our stress x. Okay, that's our stress x. Right. So for this case, I will label this point x. I will label this point y. Okay. So once I have the point, so over here, this is my stress x point. Over here, this is my stress y point. So from here to here, right? This is your Mohs circle. Okay. Now, so this is from uniaxial, right? This is uniaxial. So what you realize is stress X and stress Y are the principal stresses. Right? They're the principal stresses. So when they're principal stresses means the shear stress is equal to 0. Okay. Now, on our element now, in the structure analysis, on the element below, we realize that the loading condition is not the same as the uniaxial test. Okay, already based on formula, we already can see that stress X. Okay, we already know that stress X is equal to stress Y is equal to Py over A plus or minus mx over ix multiplied by z, okay, and then plus or minus mz over izz multiplied by x. And then we already also know that the shear zy is equal to vx over iyy qy divided by t plus or minus vz over it's zz. Do apologize. Okay, zz qz vxx plus or minus vz izz ixx qx divided by t. Well, you know the formula is different already. Okay. So how are we going to do material selection? You see where the problem is, right? And the link is what? Mohs circle, okay? Because when we construct the, let me elaborate what I mean, okay? So let's say we label this point X, we label this point Y, okay? And we know that this is not the principal plane, okay? So we draw our Mohs circle. Okay? So this is our stress X, right? And then this is our shear stress, clockwise and anti-clockwise. Okay, so now we look at point X. Okay, so point X has a tensor is equal to 0. I should have focused on compression side of stuff. Okay, so let's say then this is our stress X line. Then we have our stress Y line. Okay. Then we have our, maybe my stress Y, undo, sorry guys. I will shift this, hey, come on. So then we have our shear. Okay. Then we know that this is our, so point X is going anti-clockwise rotation. So this is X and this is Y, right? And then we know that this is our stress average. Okay. That is our stress average. So by looking at our, we can draw our Mohs circle. So you join X and Y line. Okay. So I'm going to calculate. So this is our Mohs circle. We consider our Mohs circle. It's somewhere around. This is just eyeball, okay? Okay, so we have just constructed Mohs circle. Arisha, what do you mean by could I review how to determine shear stress? Is it positive or negative? Arisha, I'm reading a student's text over there.
Yeah, I was just wondering on for the formula, it says plus or minus for Vx and a Vz for
Yeah.
and so I was